Hello everyone, welcome to my YouTube video tutorial. My name is Ben and you all are welcome. So as you can remember, in my previous video I wrote a C program that allows us to create an empty file. There was nothing much about that video, just to create a file. But in today's video, which is the second video, we are going to create a file, then write data to that file. Okay, so without further doing, let us dive straight into it. If I do my ls, you can see the former program we wrote. Okay, I don't want to mess with this program. Okay, I will just create a different directory where the new program will live. So to create that, I'll do mkdir and I'll call it my underscore YouTube. Sorry, my underscore YouTube, and that is it. If I do ls now, you can see that my YouTube is now being created. So I will do the cd to my YouTube, then I'm into it. I clear the screen. If I do ls, that there is no file stored in here, just a very clean environment directory. So the next thing we're going to do now is to use the touch program to create our empty file with .c extension. So I'll do the read underscore write, which should be the name of the file with .c extension, and press my enter key. ls now, you can see that we have the read and write.c empty file. So it's time to write our code. So I will do vim read and write.c, press enter, I for insertion key, then we can start writing our code. Hash, we're going to use the inclusion of name files. What are we including? The archive stdio, where we can access the berror function. Okay, and that is it. And we're also going to include the unis std.h archive header files, okay, which is unistd.h, and we close that. So these are the pretty two archive. Okay, we are assigning to our seed code to be able to access or reference to declared functions and define functions in the C programming language, which we'll be using in this program. So I'll do my int to write my main. Remember what I told you, that every program must have a main function. The main function tells where our CPU or program counter start executing our C code. So we'll put a return 0 just to return a success to the main function. After that, we close it. We close the block of text, the block of the main function. Okay, every function must have an open curly brace and what, a closed curly brace. Okay, so that's it. So next thing is int fd, which is our file description. Okay, fd, and I will also like to create another variable called rd, where the return read data, the string, the number of the return, the length of the return read data is being stored, and as well the write also is being stored. Okay, and that is it. So I press my enter key. Those are created now. So I will create a character as well. I will call this buff, and it should be an array. Okay, an array that we take in size of 1024. Okay, or just a let me say 15 bytes. Okay, so I will say buff size. Whenever you are creating a constant must have must be in uppercase letter. Okay, so we have to create this constant called buff size, which is this name we give to this array here, must be in uppercase letter. So we declare it above the main function. So we use the hash define. Okay, then we give the name buff size in uppercase letter, then the amount of data we want to store. So let me say 15. Okay, that is 15 characters. Okay, so this array will be of 15 characters. So let me just comment it so that you guys understand it very well. Array of type sharp. Okay, and I would also comment this buffer / asterisk, call it constants. Okay, and that is it. All right, so next thing now is to start continue writing our code. So I'm also going to create a character of pointer. I'll call this file semicolon. Okay, So that is, this file will hold the name of our created empty file. Okay, so I'll come down and I will say file, which is this pointer, is equals to data.md, okay, which is where our string will live, okay, semicolon. Then once we are done printing that, I will use the f file description, which is equals to the open system call, okay, that can help us to create this data markdown. Okay, so the open system call will help us to create this. Okay, so now we pass in the name of the file, which is this file that can help. I can use this variable called file that we can use to access this data.markdown. Put comma, then we have to pass in flag called create. Okay, and as well we'll also pass in the flag of read and write. Okay, and we also have to pass in the flag of underscore append. Okay, and that is it. Then the next thing, we pass in this 0644. I think that permission is okay. Then semicolon. Then after that, we check for errors. So we say if file description is equals to -1, then we encounter error. Then the next thing is that we are printing the error using the p-error system library function, okay, created by Dennis Ritchie. So we do fd error. So this is the error we are counting. If we enter error, the fd will just tell us the type of error. The p-error will just tell us the type of error we encounter, and that is it. So, and the next thing is to return. Okay, is to return to the main function the error itself. This will just kill our program for us. So that's it. So, but if this whole error here, from this if to this down here, our program, our file was created successfully, the compiler will just ignore all this error and move to this next line of code, which means the file data.md was created successfully. So if it is created successfully, then the next thing is to read from the keyboard. Okay, we are reading from the keyboard. Okay, we are reading from the keyboard now. Then I'm writing that which we are reading. We are writing it to the buffer, to the buff, or which is this buff here, this buff. Okay, so we use the read system call. So we say read system call. Then we are reading from the keyboard, which is 0. Then where are we reading it to buff? Then we need to pass in the size using the keyword size of what size buff, which is 15 size, 15 length in size. Press our semicolon to denote the end. Then after that, we check for errors of the RD. So if it's equals to -1, we'll press enter. Then open the curly brace, and then we are now using the p-error function to print the read, what the read is error is trying to tell, the error we encounter using the read function. Then if the error, we encounter error, we want to return that -1 to end this read for us. Press enter, we close this. But if everything was read successfully using the read from the keyboard, then this code from this if here, from this if down here, will be ignored for us. Okay, that means everything went okay. The next thing is to use to now write using the write system call. And where are we writing to? The file description, which is the file description of this open system call. Okay, so we are writing to the file description. Now this file description is holding the open system call, and this open system call is creating for us is referencing to the file variable, which is this file, and is creating in it this data.markdown for us. So that's how we're able to reference to that. So we come here, back here, put our comma. Then where are we reading the data from? Which is the data we have read using the read, okay, from the keyboard, which is the 0. This 0 means keyboard. Then reading to this buffer. So we are now reading from this buffer to the file description, which is now we are reading from this buffer, we are writing to the file description. From the file description, we are now accessing this file. From the file, we are now be able to write the data to this data.markdown. I hope this is understood. Okay, so we come down here and we put our comma and give the size of what we are writing to. So the size is of buff again. Okay, and we close this. As well, it's good to check for error. Error is always a good habit in C. So we do write WR if equal to -1. Sorry, if equals to -1, then we encounter error. Put our curly brace, then we use the P error function, and we say ROW. Okay, this is the error we encounter, and P error will just give us the error itself. Then we like to return -1, which is the error, and press semicolon that denotes the end of that return -1. So if everything we write was successful, from this if down here to this close curly brace will be ignored. That means everything was written successfully. Then after that, we just have to close the file description, okay, to denote that everything we did went successfully. So it will just close this file description that allow us to create this file, which is this file here, which the file description here allow us to create this file. Okay, but you remember that we defined this file description up here first. Okay, before you use any variable, that variable must first be declared before you can make use of it, the way we declared FD, RD, and WD. Okay, so guys, we are through with this code. This is a very clean and nice code. Okay, so any data we are writing to this buffer must not be more than 15 characters. Okay, because remember the constant here is what? 15. So make sure that it's not more than 15. Okay, so let's get straight into it. Okay, so that is it. So let us compile this code. Escape, Shift Q, Shift colon W, Q, enter. Now we are done. Do ls, we say that we just have our read write. We can cut that read write, so that I see that it's just the code we wrote. All the code we wrote, you can see it, just all the code we wrote. Okay, so that's it. We clear the screen. Now it's time to compile this code with the GCC. Okay, the GCC and the read write.c. We are outputting the our compile code to the read write. Again, we move the .c to just give it the name read write, and I press my enter key. Hence there is no error, compile error. The program will just compile successfully. Okay, it compiles successfully. If I do the ls and press enter key, you can now see we have the read write, okay, in green, which means now our program runs successfully. Okay, so I'll now have to run that file ./read write and press my enter key. Now it enter into a prompt that is ready to receive input. Remember, we will not give character more than 15, hence our program will just ignore the rest of the character. So I will say thanks, okay, comma, space, thanks for washing. Okay, thanks for watching my videos. I don't know if this is up more than 15. Let us count it, guys. Let us count it. Thanks is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's more than 15. So we have to thanks, guys. Okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Thanks, guys. I'll just put 11, 12, 13, 14. So I'll just put it like this. Okay, so this is 15 bytes now. So press enter key. Now you see it's now written to the data.markdown. If I do ls now, you will see the data.markdown is there now created. Okay, but we don't see these thanks, guys, we just wrote. So for us to see it, we have to cut the data.markdown. That means I'll say data, okay, .markdown. Now press enter. You can see thanks, guys. Okay, so what's up, guys? I hope you guys enjoyed this video and you love what we just did. You can as well make the byte more longer, the size of the byte more longer, to write more data, okay, to the data.markdown. Okay, this is just for an educational purpose, just to teach you guys how beautiful C is, and you can see how fast the code is running. Okay, and that is one of the ability of C. Okay, and those of you that have been watching my videos, thanks you guys. God bless you all. I appreciate for what you are doing. Please encourage me by watching my videos, liking, commenting, subscribing to the channel, my YouTube channel, and all that. Okay, see you guys on the third video, and God bless you guys. It's your boy. Please make sure you like, please make sure you subscribe, and turn on what? Notification bell. Please, I beg of you all, please like, subscribe, and turn on notification bell, so that whenever I drop a new video, you receive notification that Pen has dropped a new video, and go and watch it. Okay, thank you for you guys. It's been education hanging out with you guys. See you guys on my next video. Bye.